Hello Math 7 students. This is a very brief instructional video explaining how to measure angles using a protractor. Although measuring angles with a protractor is an old skill that you learned in 4th grade, from what I've already observed from students in class, it's a skill that we definitely need to be retaught and have some practice on. So, to get started, we are going to need a protractor. Students in class will have access to this type of protractor. If you're working from home and purchased your own, you more than likely have a protractor like this. The good news is they work the same way. The bad news is this one is a little bit more challenging when we're measuring angles that have smaller lines. So we'll be talking about that. No matter which kind you have, I want you to observe some key features of the protractor. And the first is, on each protractor, there is a bottom line. You can see that bottom line here. Notice I'm not highlighting the bottom edge. I'm highlighting this bottom line. Here on the orange protractor, you will see that again, it's not the bottom edge, it's this line right here. Notice, again, on each one of these, we also have this sort of middle point. In this orange one, we see the middle right here with the hole. In our solid one, we can see the middle is represented by this line that goes straight up. So this point right here is going to be that middle. You'll also notice that on the outside, we have two sets of numbers. Starting at the right-hand side, on the inside, we start with 0, and then we count up 10, 20, 30, 40, and so on, all the way until we get all the way around to 180. We see the same thing here. It doesn't show the 0 because the 0 is actually this bottom line right here, but it does count up 10, 20, 30, and so on, all the way around until you get to, again it says 170, knowing that it goes all the way to 180, that would mean that this bottom line here is the 180. On the outside, you will see starting at 180 and counting backwards until you get down to 0, and same thing here, 180, counting backwards until you get down to 0 here. I want to focus on measuring using these inside measurements. Okay, so although we can see the outside, I want to focus on using the inside, and that's how we will be measuring. So I'm going to kind of switch for just a second. I'm just going to show how to measure using this smaller one, and then we will switch over to the bigger one. Here I have two angles, and what I've done with these two angles, or what I'm going to do with these two angles, is I am going to measure. So it's important that you find that middle part, because that middle part of your protractor, that is where you line up with the vertex. Let's go over some quick terminology. An angle has a vertex. That's where those two lines or line segments are raised that form the angle come together. That right there is the vertex. So I need to line up the middle of that protractor with the vertex. You also need to make sure that the bottom line, that would be this line right here, is lined up with the 0 line. Again, not the bottom edge, but this bottom line. So lining up that protractor, I can see that I've got that bottom line. It looks like it's off right now, so I'm going to twist it into place. Now it's lined up, and I just need to make sure that that vertex is right there in the middle. Looks like I got off just a tiny bit in doing that, so hopefully we're in alignment now. And when I'm taking a look, I can see that behind these lines on the protractor, that's where you can see this line that forms the angle that I'm actually supposed to be measuring. So it looks like, I can follow that all the way up, looks like it's past the 50. It's not quite to the 60, so then we have to keep on going and see if we can kind of count those marks down on the edge. So although this says 130, please note that that 130 is lined up there with the 50. So we can count 50, 51, 52, and I would estimate that this is about a 53-degree angle. Let's take a look at how we will do that with the protractor that has a hole in it. I am still going to be lining it up. This time, as I line it up, I'm lining it up there with the hole. And I've made this a little bit fat. Let me get that cleaned off. So, lining up the hole with the vertex, and again you can see through that protractor, so I can make sure that I'm twisting it so that this bottom part of the angle here lines up with this 0 line. So it's not in place yet, so I'm going to twist it a little bit more until it lines up perfectly. And I've got that vertex still in the hole. So now I can measure the angle. Only now you can see the trouble is this angle, the line that forms the angle has been made too short. So I can't see how to measure it. So what you're going to have to do, if you have a protractor that has a big hole in it like this, you're just going to use the edge of your protractor and you are going to form a nice straight line that extends past that. So I'm using the straight edge of the protractor. I'm extending that line as much as I need to. And now, as I place that protractor back into position, with the vertex right there in the hole, twisted so that that bottom lines up perfectly, now I can use that to measure and see just how big that angle is. Now this protractor is kind of nice because we can see the 50 and we can count 1, 2, and it looks like it's kind of between the 2 and the 3. You pick which one it's closer to. Again, I would say that it's 53, and that gets me that same estimate that I used with the other protractor, so 53 degrees. That's the basics. I'm going to do one more using this obtuse angle. Obtuse angles are angles that have measures greater than 90 degrees, and so this is obviously greater than 90 degrees because it's more than that perfect right angle corner. So as I measure this angle, I'm still going to place the middle of the protractor there on the vertex, again twist it until it's in place so that this bottom line of the angle lines up with the 0. And now I can count around and see we've got 0, 10, 20, 30, 40, 50, and so on. We're passing the 90 because it's bigger than 90, continuing on, and it looks like it's going to be between the 130 and the 140. And if I go up a little bit further again, we can see that this 150 or this 50 lines up with the 130, 140 lines up with the 40. So we can kind of use that to count, right? So this would be 135, 36, 37. So it looks like this is a 137 degree angle. Again, I'll put that in position there so that you can see. We're at 130, and then we have to count up 1, 2, 3, 4, 5, 6, 7. 137 degree angle. So what does that look like using this other kind of protractor? Same thing. Okay, we're still going to line it up, but I'm like, oh no, I can't measure, right? So we're going to twist it and use this as our straight edge to make that line even longer. That should be long enough so that now when I replace the protractor in position with that vertex in the hole, twisted so that the 0 and the bottom of the angle line up. And now again we can count around and see we're at 130. Looks like we are a little bit shy of the 140. Looks like 149 degrees. Excuse me, not 149. That would be 139 degrees. Because 40, and we're going smaller than that, so 140, 139, or counting up 30, 135, 36, 37, 38, a little bit more, 39. So I got a few different numbers here using different protractors. And that's only because we can only be as precise as our tools allow us. The challenges that we have are you have to tell me when this is lined up. Is this lined up? Do I need to go a little bit further over? Do I need to go a little bit further over? And so we're going to have a little bit of error just because our measuring devices are only so accurate. Also look at the thickness of the line, and then it got a little bit thinner, so maybe that played into it a little bit. It's okay that these were a little bit off from each other. Okay, I'm only asking you to be precise as well as you can be with your tools. So if you're off by 3 or 4 or 5 degrees, you'll probably be okay. If it's more than 5 degrees, then you might need to go back and remeasure. So there's your instruction. Let's do the first one on your paper together. The rest of them you will be doing on your own. Again, if you're using this protractor, you'll need to extend the line. In-person students, you will be using this protractor, and so I'm going to get this in position here. Twisting it right to where it needs to be. That looks like it's lined up perfectly. And now I can see that line actually almost disappears because it lines up so perfectly. Can you see it? There it is on our paper. I'm going to go ahead and make it red so that it's easier to see underneath the paper. And now it looks like that lines up perfectly. 10, 20, 30, 40, 50, 60, 70 degrees. So I would measure this as a 70-degree angle. The first couple you are going to notice end up really nicely on one of those lines. Then they progress to harder and harder and harder, and then you're really having to try and count. So I want you to do all 20 of those problems. I know as you're looking ahead, you're already saying 6, I can't measure 6, it's not an angle. It is an angle. I want you to put that brain to work. Think about what kind of angle that is. Put your protractor on, see if your protractor helps you measure that angle, and then we will talk about it when I return. That's it. Have a great day, and we'll see you next time.